Good morning to all of you. My name is Dr. M. Ratnarazu. I am working as a lecturer in the Department of Physics, Andhra Christian College, Guntur. Today I am going to give some information regarding the optical fiber, working principle, description and its working, applications, uses, advantages and disadvantages. Now let us see. This is the diagram, an attractive diagram of optical fiber cable. Now, what is an optical fiber? An optical fiber is made of a flexible and transparent like structure made by using glass, that is a silica, or plastic whose diameter is slightly more than that of a human hair, to transmit light energy from one place to another with minimum loss of energy. The working principle of any optical fiber is total internal reflection. What is total internal reflection? When a light ray travels from denser medium to rarer medium, such that if the angle of incidence is greater than critical angle, the light ray, instead of refraction, gets reflected into the same medium. This phenomenon is called total internal reflection. So the working principle of optical fiber is, as I told, it is total internal reflection. Now let us explain about total internal reflection in detail. Now let us consider this is water, that is denser medium when compared with air medium. So here the light ray is traveling from denser medium to rarer medium, that is from water to air medium. So this is the light ray incident on the boundary. So this is the boundary separating water and air. So this is the point of incidence, and this is the normal drawn at the point of incidence. So this is called incident ray. So here the refracted ray has bent away from the normal because the light ray is moving from denser medium to rarer medium. So here theta 1 is called angle of incidence and theta 2 is called angle of refraction. Now come to the second diagram. Now here the refracted ray is traveling along the boundary separating the two media. So here this is angle of refraction, and that angle of refraction is now it is 90 degrees. So if the angle of refraction in the rarer medium is 90 degrees, the angle of incidence in the denser medium is called critical angle, represented by the letter C. So here it is represented as theta C. C stands for critical. Now let us come to the third diagram. Now here, this is the incident ray. So actually, the light ray has to enter into the air medium. But here, the angle of incidence is greater than the critical angle theta c. Since the angle of incidence is more than critical angle, the light ray gets reflected into the same medium. So, this phenomenon is known as total internal reflection. So, this phenomenon is used as working principle in optical fibers. Now, what are the conditions for a light ray to undergo total internal reflection? Now, there are 2 points. First one is, the light ray must move from denser medium to rarer medium. The second point is, the angle of incidence must be greater than critical angle. If these 2 conditions are satisfied, then only we can observe total internal reflection. Now, this is the example for the demonstration of total internal reflection. Now, see here, I have taken some water in a bottle, and here I have switched on the light. So, light ray is moving from water medium to air medium, that is from denser medium to rarer medium. If I maintain the angle of incidence is greater than critical angle, the entire light energy gets reflected into the denser medium. So, we cannot observe any amount of light entering into the air medium. So, that is the total internal reflection. So, here both the conditions are satisfied. One is the light ray is moving from denser medium to rarer medium, and the angle of incidence is more than critical angle. Now, let us see another. See here, this is another demonstration. Now, here I have considered the green color light. Here also, the light ray is moving from some denser medium to a rarer medium, that is air medium. So, here it may be of any liquid. But when compared with this air medium, it is denser medium. Therefore, first condition is satisfied, that is, the light ray is moving from denser medium to rarer medium. And the second one is, if I maintain the angle of incidence more than critical angle, then the light ray gets reflected into the same medium. So, that is another example for total internal reflection. Now, this is the famous example that we use even in intermediate standard. So, the formation of mirages. The formation of mirages also takes place because of the phenomenon of total internal reflection. Now, let us see the optical fiber, how it works. Now, if I consider any optical fiber, there are 4 parts. The 4 parts are, first one is light guiding core, second one is cladding, third one is primary coating, fourth one secondary coating. Among these 4 parts, the primary coating and secondary coating are only to protect the optical fiber structure. So, the main components of optical fiber are 1. Light guiding core, and second one is cladding. Now, let us see the description of optical fiber. It is a long cylindrical transparent structure with a cylindrical cross section. And the second one is it has two coaxial regions. The inner region is the light guiding core and the outer region is cladding. The cladding is surrounded by two coaxial layers which acts as a supporting structure to protect the core and cladding. Now let us see how the optical fiber appears. Now if you see, this is the diagram of an optical fiber. So this is the central portion is called core, which is the very important part of any optical fiber, and the diameter will be of very small, and the core is surrounded by called cladding. So this black one is called cladding, and the cladding is surrounded by another protection, that is plastic fiber. It's made of plastic fiber, and that is the primary coating is surrounded by the secondary coating, that is called outer jacket, which appears yellow in this slide. So for all these regions the axis is common, hence they are all coaxial cylinders. Now let us see the another view of optical fiber structure. So this is the plan. If I see from the front side of an optical fiber, it appears like this. So here the blue color one is the core material. So it is the main part through which the light energy travels from one end to the other end without any loss of energy. And this is surrounded by a material that is called cladding, So here glass cladding, and it is surrounded by the primary coating, that is the primary coating. So plastic covering. So that is used to protect the optical fiber, and it is surrounded by the secondary coating. Now let us see in detail about the diagram, schematic view of optical fiber. See here the various regions of optical fiber are represented with various colors. So this is core, fiber core. If you see the diameter, it will be of very small, and it is surrounded by cladding. Say it is 125 micrometers, and it is surrounded by, that is primary coating, secondary coating. If you see how the diameters, so it's very small diameters the core and the cladding will have. So this is the schematic view of optical fiber. And so if I consider an optical fiber, so here this is the signal that I want to send from one end to the other end by using an optical fiber. So whenever I switch on this light, so the light ray enters into the optical fiber. So here it undergoes total internal reflection, and here also it undergoes total internal reflection. So the light ray, as it moves from one end to the other end of the optical fiber, the light ray undergoes total internal reflection many times. Hence, so here we are having the receiver. We can receive the signal sent from one end. So here I can have a receiver so that I can receive the signal sent at the other end. Now here if you see, so this is say that is an optical fiber, Here I have considered two wavelengths, and they are made to enter. Then the light ray undergoes total internal reflection. See the blue color and the red colored light. So they can be called as signals. So the signals can be sent